So on to the last video I'm going to make. So this is part 3 of 3. I've had a few software issues here, we're just going to keep going. So we talked about section 1 of the graph, and we've already talked about section 2 of the graph. In section 1, remember, because the temperature was increasing, the kinetic energy was increasing, the kinetic energy store of the substance was increasing, and that led to the internal energy store of the substance increasing. In section 2, the kinetic energy store is constant because the temperature is constant, and this is always true at a change of state, whether it be solid to liquid or liquid to a gas. However, the heating that's happening, the energy from that is going into the substance, and it's increasing the average separation of the particles, and that is increasing the potential energy store of the substance, and so the internal energy of the store does increase. Internal energy store of the substance does increase. Excuse me. So on to the last section then. So once the object has finished changing state, and we were talking about ice going to water, so our change of state happened at 0 degrees. Further heating, the energy from that will cause the temperature to start increasing again, as you can see from this line here in section 3. You can see the line is going up. Wonderful. So that means that the kinetic energy store again must be increasing, and that leads to an increase of the internal energy of the substance. So I've summarized that in point 3 down here. The temperature is increasing, so the kinetic energy store of the substance is increasing again. However, the substance is no longer changing state, so the potential energy store is not changing. So this is a typical heating graph and how to interpret it, and the stages were always the same. So if the temperature is changing, the kinetic energy store of the substance must be changing. So if temperature is going up, the kinetic energy store must be going up, and the internal energy store must be going up. If an object is changing state, onto point 2, it happens at a constant temperature, and that means that there's no change to the kinetic energy store of the substance. However, the internal energy store does increase, because that energy from heating is going into increasing the average separation of the particles, leading to an increase in the potential energy store of the substance, and then the internal energy store goes up. So feel free to review these 3 videos as much as you need to, and copy down notes by using pause. A good student would build a good set of notes, and expect to have to interpret heating graphs like this, and you need to be able to talk about the flat bits and what a constant temperature means in terms of kinetic energy, potential energy, and internal energy, and bits with a constant gradient. The sloped the lines which went upwards to the right, you need to be able to interpret these in terms of what's happening to kinetic energy, and what's not happening with potential energy, and what's happening with internal energy. So the links are always the same. You're going from changes in temperature or not, interpreting that in terms of changes in kinetic energy store or the potential energy store, and then interpreting that in terms of changes in the internal energy store. The sequence is always the same. So I hope this is helpful, and I hope you're getting on alright in lockdown. I'm sure we'll be together soon in FCC, and keep going. I know that it's all a bit different at the moment, learning remotely and losing contact with people. Things tend to look a bit the same, don't they? But we'll all keep going, and hopefully we'll be back in school before too long. Okay, take care, bye bye.